Okay, sorry about my terrible writing, but we're going over higher order derivatives. All that means is you're going to now take derivatives of derivatives. Okay, it's like rinse, wash, repeat. Okay, wait, now rinse is wash and rinse, and then repeat. Okay, so here's my example. If I say f of x, iPad's lagging again, minus x squared. Okay, and I ask you guys to take just the derivative. And we denote the derivative by this little mark, almost like a little slope. Okay, so go ahead and take the derivative. Super easy, right? 3x squared minus 2x. And all the higher order derivative is, take the derivative again. And we denote that with a double prime. So a single prime means the first derivative. 2 primes means second derivative. And that's it. That's the idea. Now, with polynomials, this is always going to be super easy. If f of x is equal to 6x to the 10 minus 4x to the 5th minus 5x, okay? And I can ask you to take the fourth derivative. So I'm going to denote it with the number 4. So walk your way down. Start taking derivatives. F prime is 60, x to the 9 minus 20 x to the 4 minus 5. F double prime is equal to 540 x to the 8 minus 80 x, and then this is gone, negative 5 is gone, f to the third. So we denote the third derivative with 3 primes. And after 3 primes, you just write numbers. Now, I don't know what 540, 500 times 40 is 40, 4320, 7 minus 80. Was that right?
Yes.
Cool, yeah. And then the last part, we have to do one more derivative.
Wait, didn't you
can't do that.
Forget some powers? Wouldn't it be?
Well, oh yeah, you're right. This is a 3.
Third and then
thank you. Whoops. You're right there.
It's 30,240.
Thank you very much. There you go. And that's all it is. So for polynomials, of course, it's pretty easy. But everything else besides a polynomial is kind of weird. Now let's do sine. If I do f of x,
Mr. Coe, wouldn't it be?
Sorry.
Wouldn't the for the derivative of 4 or whatever? Wouldn't it be minus 480x?
Oh, sorry. Thank you. Darn it. I think I got distracted. Okay, so you're right. Let me change this. So this is 1 for, you said 240, right?
Yeah, 240 and then 480.
And then 480. Thank you. Totally messed up there. Okay. Simple mistakes. So just make sure you're not distracted. There you go. So let's do something else. Let's do our trig functions. Let's do sine. Let's find f. Let's just do double prime. What is f double prime going to be? So we just walk our way through the problem. F prime is cosine of x. F double prime then is the derivative of cosine. And that's going to be negative sine of x. So to write this slightly differently, we could write this as d over dx of sine x, okay? And then we're then going to take the d over dx of that again. And I want you to see the notation for this. To come up with the second derivative, if you essentially distribute this out, right, doesn't that become d squared over, hey, don't you have two dx's? So we write this as dx squared. This notation here is the same as this one, f double prime.
So then so on, you just cube it and stuff like that?
Yeah, but it's kind of interesting. It is kind of confusing because when you see someone write the derivative, if they say y is equal to sine of x, and they say, hey, find the second derivative, whoops, this is how they write it. They write it specifically with the squared next to the d, not the y. Oops, it's written like this. And that means take the second derivative. We've seen this before where we just say, hey, if y is sine, then if I ask you to find dy of dx, this just means take the first derivative. That's the basic idea. Now for this problem again, if I write it this way, when I first learned calculus, I found it kind of weird. Why didn't they write it this way? Why is the squared in front of the, sorry, behind the d and not the y? And this is not the same meaning. Okay. So our notation, when we say d squared y, it really comes from this idea here. Take the derivative of the derivative. Take the derivative of the derivative. So I'll write this in a couple of different notations, all meaning the all meaning the exact same thing. Sorry, I keep cutting out because my tablet's acting up. I don't know why. I don't think it's my internet connection anymore. Okay. So let's go back and do this problem. Except with, we'll do tangent. So if y is equal to tangent x, what is y double prime? Okay, so we have a lot of different ways of writing this notation. We can write it in f. We can write it in y. This is the same as d squared y over dx squared. Sorry. Same notation. It just means take that second derivative. So don't let the notation. So don't get messed up by the notation. It really is all referring to that second derivative. Okay, so let's do it. Y prime is equal to secant squared. Okay, and if we take the derivative of secant squared, careful, that's power rule, right? This could be written as secant
X squared
like that. You have to write the parentheses. If you don't write the parentheses, you might think it's secant x squared, thinking it's that. Okay, so you might think it's the square goes to the x, not for the secant. And that in this case, well, this is just power rule. Y prime is equal to 2, leave the inside alone, secant x, 1. And if you remember what the derivative of secant is, it's secant tangent, excuse me, bless me. So our y prime.
But Mr. Koch, can you...
Sorry, that's our second derivative, my bad. Second derivative. Go ahead.
Can you remind me what we do again when we do like the front, back, leave the inside, all that stuff?
Okay, so I'll write this really big here. Secant squared x. And we want to get the derivative of this. So y double prime would be, since we write this as a squared like that, we bring the exponent to the front. 2, leave the inside alone. right? That's our chain rule. Leave the inside alone. Then multiply by the derivative of the inside. And the derivative of the inside is secant x tangent x, right? The derivative of secant tangent, excuse me.
So what was the rule again? It was like do the problem first and then do the inside or
Are
something
you talking
like
about chain rule?
Yeah, what was chain rule again?
Chain rule is always take the derivative of the outside first, followed by the inside. So to repeat the official rule for chain rule, it is, let's say d over dx of f of g of x, where g is inside a bigger function f. So I'm taking this derivative. We first derivative take the derivative of the outer. So it's going to be, we can just write simply as f prime. Leave the inside alone, pristine, not changed. Then multiplied by the derivative of the inside times g prime of x. That's the basic premise of chain rule. And this could be repeated over and over if there's multiple chains. To show you an example of this again, let's say d over dx of sine of x squared. The outside function is a sine, so the derivative of sine is cosine. And we leave the inside alone. That's our g of x. Then we multiply that by the derivative of g of x, which is 2x. If you want to do chain rule again, right, the derivative of x is 1. Is that invisible 1 that we don't write. Okay? And this rule translates to, let me do one more. D over dx. If I do, let's do secant x squared. We say what's the derivative of the outside function first, then followed by the inside function. So the derivative of the outside function is secant tangent. Oh, so yeah, secant tangent. And we copy the inside value because that does not change. Even though we have to repeat it twice, it's still the same function. We multiply by the chain rule, which is the derivative of x squared, which is 2x. Okay. So if you notice, the pattern is that the outside derivative, right, that's the outside derivative. Derivative of the outside, leave the insides alone, multiplied by our chain rule, by the derivative of the inside. And that's always the case. So that's why, like, for instance, our second derivatives can get a little confusing because the first derivative was easy and then it gives us something kind of terrible and we have to take the derivative of that. Now, let's go ahead and do the derivative of secant twice. Let's do this again. D over dx, because secant gives us, as we saw, some really weird derivative. Secant, and we'll do secant of 2x, okay? Find the, and we'll write this way. So find the second derivative of secant 2x. Yeah, I know I keep freezing. My audio doesn't freeze anymore. Is my audio still freezing? Okay, let's give this a shot. Okay, so we take the derivative here. Let's see if the writing comes on. No. Come on. Let's go writing. Okay, a little bit laggy but slow. Oh gosh. Okay, we first take the derivative of the outside. And so let's just write it separately. So if we take our, forget, we'll do it this way. Okay, and the idea is this is, oops, d over dx of secant 2x. That's the idea. So let's take the derivative of our secant squared, which gives us, secant of 2x, gives us secant 2x tangent 2x times 2. Right, that's our chain rule. To rewrite this a little bit easier for us, d over dx is constant 2 secant 2x tangent 2x. Now, to go through the methodology of this is, since 2 is a constant, we we can throw the 2 out. d over dx of secant 2x tangent 2x, just so it's a little clearer. Now the problem with this problem is that now we need product rule. Oh no, product rule. So we say the derivative of the front. So let me think how I should write it. Now let's just take the derivative. The derivative of the front is secant 2x tangent 2x times 2, chain rule. Leave the back alone. Plus the derivative of the back. Remember what the derivative of tangent is? That's secant squared 2x, chain rule times 2, leave the front alone. Whoops. I don't know I wrote that. Secant 2x, close that parentheses. So rewriting this whole thing, I see a bunch of 2's. I can take out a 2 here, I can take out a 2 here. That's my common 2. So we end up with 4 in the front. We end up with secant 2x tangent squared of 2x plus secant cubed of 2x. So the more derivatives you go, it does get a little more messy because you're dealing with the mess you just created. And sometimes these derivatives get a little messy. Now let's do another problem. If I say y is equal to 1 over, that's not the 1 over, let's just do the square root of x. The square root of x. Okay, just the square root of x. Not terribly terrible. So let's find the second derivative, y double prime. So we take the first derivative. It's automatically 1 over 2 square root. Leave the inside alone. And if you want, you can say 1 again if you want to, because of chain rule. Now I'm going to rewrite this as 1 over 2 x to the negative 1/2 power, because it's going to be easier for me when I take that derivative again. So when I take this second derivative, it becomes negative 1 over 4, because the 1/2 goes to the front. And it'll be minus a 2 over 2, right? Minus 1. So we're left with now x to the negative 3 over 2. Oh yeah, 3 over 2. And that's our second derivative. To rewrite this as a fraction, negative 1 over 4, the cube root, the square root of x cubed. If you want to rewrite this to simplify, which you don't have to, please, over 4x, and then it's the square root of just x. Okay, any questions? Feeling okay about this? The problem with higher derivatives is just you have to know your rules really well. You have to know your rules really well.
Is the test going to be like the first test where it's through the textbook software, or is it on Schoology?
I haven't decided if I'm going to use the textbook software or I'll go through Schoology, or I might actually try a new platform. The new platform I've been looking at. Yeah. Okay. But actually, no, the testing software isn't bad because you have the ability to go back and look at your mistakes. And that's the problem with my my pre-calc class. That book software is too old and won't let you do that. So that's one of the things I was afraid of, that you guys couldn't go back and look. But I might just go back to the book software. Okay. Since it does give you guys feedback, which was my main concern.
And the test is on Thursday, or?
No, I want to bump it. So we'll do, since we're doing second derivatives today, I'll set up the review. I'll try to put it out today, and then we can go over some questions. So we'll do it, darn it. But if we do it Monday next week, it's going to be too short.
Yeah.
So why don't we aim for Tuesday next week?
Okay.
Okay, Tuesday next week. So I'll put it in the calendar. I'll put it up on Schoology. Tuesday next week. Everyone test Tuesday next week.
Mr. Koch,
Yep, Dove?
on the test, are there gonna be any like tangent lines, or is it gonna be all derivatives?
It's all just straight derivatives. It's just as fast as you can go.
Sounds good. Thanks.
As fast as you can go. But because it's as fast as you can go, I can give you more problems. Yeah, so that's just what
I
it is.
like the more problems because on the last one it was 15. So if you missed 2, you were already in like
Oh,
the 80s.
so you like
you know?
more problems because every wrong mistake hurts you less. Got it.
Yeah. No, it's valid.
I'm seeing a lot of
15
shaking heads
questions.
here.
Like, there's a lot on each question.
Yeah. Okay, let's look at some other tricky ones. What if I have, let's find the y, if y is equal to, let's say 1 over x to the fourth plus 1 over 3x cubed. If I want to find the second derivative. Okay, so you could keep it this way, but do you really want to do product rule? Nope. So I'm going to rewrite these as y is equal to x to the negative 4 plus 1 over 3, because that's just a stupid constant. I don't care about constants. Negative 3. I think this is the fastest way for us to do this problem. So when I take my first derivative, that's negative 4x to the, careful, negative 4 minus 1 is actually negative 5. And that's going to be 1/3 times 3. Oh, that's a negative, so it'll be a negative x to the negative 4. Because when we move the 3 to the front, that's negative 3 over 3 becomes negative 1. Following up with that, it's y double prime. So we take the derivative of this again, but now it's a power rule, super easy. 20x to the negative 6 plus 4x to the negative 5th. Okay, so let's give you guys a nice bountiful mix now. If I ask you guys for the second derivative, y double prime, for y is equal to, let's do 2 the cube root of x squared plus 1 over x cubed plus sine of 2x. Something nasty. Okay, so 3 different skills. Now I'm going to rewrite some of these, I think, to make my life a little easier. So to rewrite this guy, it's 2 x to the 2 out of 3, because I have 2 looking for 3. I have 2 looking for 3, 2 out of 3. Plus x to the negative 3rd power. Exponent becomes negative when I write it on top. And that's sine of 2x is pretty easy. So I think a big deal is don't overthink the problem. Just follow the rules that you know. Y prime is 4 over 3 x to the negative 3 over 3. That gives me negative 1 over 3 as the exponent. Be careful about those fractions. Bring down the negative 3. That's negative 3 x to the negative 4. We subtract 1 from it. Plus cosine of 2x. And we'll stick the 2 right in front to save me some time, because this is my chain rule. Okay. I should draw some symbol like a chain. I should like draw a chain or something. Chain rule. Okay, now we take the second derivative. Following the process, bring down the exponent. So it's going to be negative 4 over 9 x. If I minus 3 over 3 again, that's negative 4 over 3. I think me writing the fraction on top helps a little bit. Plus 12 x to the negative 5th. And now we have a constant multiple, so we can ignore the constant. But our cosine is negative sine of 2x. And then we're going to multiply this by 2 again. I'll stick the 2 in front. Simplifying the problem, y prime double prime is equal to negative, you don't have to rewrite it this way, but I want to just rewrite it, negative 4 over 9, the cube root of x to the 4th, plus 12 over x to the 5th plus, sorry, not plus now, it's going to be a minus 4 sine of 2x. Okay, any questions about higher order derivatives? They're just a little messy, right? I would say they just get a little messy, and that's it.
So you said we don't have to rewrite it in the final way?
No, okay, so
Or-
for the test, I'm trying to think, it depends how the software does it. If I wrote this test myself, I would actually just have you take the derivative and don't simplify. That's it, just take the derivative, don't simplify, and we're good to go. And but I'll take a look what the software says, because if not, I might just write a Schoology test. I still need to look at it. Okay, but I'll let you guys know definitely before Tuesday. I'll let you know by Thursday. Okay. Wait, today's Tuesday. Yes, I'll let you know by Thursday.
The test is next week, yeah?
Next week on Tuesday.
Okay.
Right? Do we have time? What time is it? 12? Oh, we have time to keep going if you want, but it's been like 40 minutes. All right, anyways, we'll call it a day then. So if you haven't caught up with your work, I know a lot of you guys haven't caught up yet, so make sure you do catch up. And I won't give you guys any more than this. If I can make a review, I'll make a review today, and I'll post it and I'll email you guys about it. Okay. Besides that, sorry about the technical difficulties. I'm still trying to figure it out. Okay. Besides that, if you have any questions, you guys can stick around. If not, see you later.
Thank you.
Thank you, Mr.
Thank you,
Ko.
Mr. Ko.
Thank you.
Thank you.
Bye, Mr. Ko.
Bye. Why is it so laggy?
Unsurprisingly, I also have another question
Yeah,
about how to do specifically multiple trig functions
Sure.
in sequence, like taking the derivatives.
Yeah, shoot.
I was doing